Um, so I won't talk very long, but I want to start by thanking you in a very specific way. I think that this PMC, as I've gotten to know it, it's my 7th year riding, has been, I think, the thing that has kept me and my family and my work in Boston. It's a very unique thing you do. You must know that everywhere you go and you tell people you're a part of this, they can't believe that it would bring in such a resource at this desperate time when resources are needed to fund research. And the experience of riding as a doctor with patients and survivors is always very powerful, but this year was very different, riding with all of you. I got to know Rick and Erica at a time when she was very sick, and there was a need to think outside the box. Would there be therapies that the sarcoma community might not have thought about? Would there be therapies that, based on genetics, could be useful? And my lab is a drug discovery lab. We live in academia because in leukemias, which is the focus of my lab's work, all the drugs are hand-me-downs. No drug companies out there hoping to make a leukemia drug. All our drugs failed for some other purpose, or they were derivatives of the gases that the Germans used to bomb the Italians, or they were dyes from the dye industry that were proven toxic. All of our drugs are hand-me-downs. But our field's very sophisticated. We found ways to use these drugs. As I started to dig into the science of LMS, it was very thin. You could read the whole field of science in a long afternoon. There wasn't much known. It's fair to say that there's no drug company that's dying to make a sarcoma drug. And in fact, I'm not sure a drug company has ever made a drug for sarcoma. Even GIST, this miracle of drug development with George Dimitri at Dana-Farber, this drug is an accidental leukemia drug initially developed for larger impact cancers that was then accidentally used in GIST, albeit shrewdly. So if you have sarcoma, where do your drugs come from? Now, we make drugs in our lab. I have a chemistry lab. We have built at Dana-Farber this capacity to do chemistry and biochemistry and cell biology all together, but without the influence of commercial considerations or how many people get this cancer or that. Like most science at Dana-Farber, we're just trying to do the hardest, coolest thing we can. And there's a lot to do in the leukemias. And so last year, Rick and I sat down and he said, what would you do, with the resource of this ride? And I said, well, I would give you the best advice I can on who in this field to fund. And then this year came. And with Erica's passing, Rick came back and he said, I don't want advice. We want you to do something with this resource, something different outside of the box, the sarcoma world. And with no disrespect to the people in that space, because there are some amazing and talented scientists there, some of whom are in our community and at Dana-Farber and their colleagues, what we realize is that there are no targets. That before there can be drugs, the chemists need to know what to drug. And genome sequencing we thought would bring all the targets, but when the sarcomas were sequenced and LMS was sequenced, it was these same targets, these same cancer-causing genes that haven't had drugs for 30 years. Who's going to make those drugs, right? So in the last 2 years, we learned that beyond the GAs, Cs, and Ts, the language of the cancer genome, the mutations that cause the cancer, that there was a new way to look at the genome. And I won't bore you with it. You go right to sleep tonight. If you have children like mine that can't sleep, I'll come over and tell them the story. But it turns out that cancer cells have memory, that they can remember their cancer. When they have all the genes needed to make a finger, but we never find a finger inside of an LMS mass, we just find more LMS. How do they remember that they're cancer? And so we worked with the top biologist in the world on this, a guy at the Whitehead Institute named Rick Young. And we created a technology that lets us find all the memory factors around the genome. And would you believe that there are parts of the genome that have mountainous piles of memory factors? Like huge chips at the poker table, or I should say, I don't know a lot about gambling, but what's the one with the wheel? Roulette table, is that when you have a huge mountain of chips on 7, you walk up, you're like, what is it with you and 7? Well, I'm you know, it's my 7th house, I'm on my 7th business, I've had 7 surgeries. There's a story there. With this technology, we can understand by looking at what we call the epigenome, what the most important genes are to a given cell. And so the biologists love it because it tells you how you make blood out of skin or how you make a mouse out of fibroblasts. And we've done all that stuff, but that's a party trick. What we want to do is take a disease that for its entire history has never had drug targets and just enumerate the locations of these mountains and say to the community, here you go, here are the targets, now make drugs. If you did this at a drug company, naturally you would keep that information secret, but the luxury of being at Dana-Farber is we're a charity. And the luxury of not being a sarcoma doctor is I'm not trying to take over the sarcoma world, nor is my lab. So with Rick's insight, we've put together a team of the best people he knows in that space, and a team of the best scientists I know outside that space, and the best surgeons to get the tissues. And we will create these landscape pictures of the sarcomas, each of them, the discrete known sarcomas, and put all this information into the public domain in real time for anybody, anywhere to study. And we'll give them the tools to understand it if they're not familiar with our science. And we will literally spit out lists of genes that need drugs, and if there are drugs for those genes already, they go right into the clinic. The purpose of this project is not to do biology, it's not to publish big fancy papers, it's not to get, you know, Rami and Alex and all the people in my lab working on it PhDs. We have all those things already. The purpose of this project is to cure this disease through the identification and drugging of new targets. How will we know that we're successful? We'll know we're successful if a year from now we start a clinical trial based on one of these insights. And if 2 years from now drug companies jump into the LMS area because they regard it, having been told what to do, as a great opportunity. If 5 years from now we start to see patients respond with these diseases to agents targeted at them. So it's planting a seed. It's planting a $800,000 massive seed. But don't look at it as funding our lab. Don't look at it as funding Dana-Farber. We are able to do this trick, this science, but these insights will go literally out around the world for anybody and everybody to use with no intellectual property or proprietary anything, just to get the word out there that we understand this disease better now and we can do something about it. Now, LMS is just one sarcoma. What I learned over the last 1 year is that 10% of the people that walk in the door, the pathologists at Harvard actually don't know what kind of sarcoma they have. They call it uncharacterized. They look at it under a microscope, it looks amorphous. They can't figure out the diagnosis. And the leading pathologist in the world, Chris Fletcher, is at Brigham and Women's Hospital. So one thing we expect is that this fingerprinting of the cellular's memory will unambiguously diagnose everybody's sarcoma. And it will take some time to make that a reality, but I think beyond just the therapeutics, we'll have this new era of diagnostics that will help the field well beyond LMS as well. All right. So this year, it's biology, it's genomics, it's open source of this data set, and then if we get together next year under whatever team name or just under the tent at the PMC at the Harpoon Beer area, you should ask me how it's going. We'll move into new lab space in January. This is, again, Ed Benz's commitment to drug discovery at Dana-Farber Cancer Institute. We're expanding this program substantially. And I think this group should come 6 months from now, and we'll cook dinner for you. And it will not taste as good. And we'll have you out for the interim report on how it's going in 6 months. But I finished where I started. We've never been challenged in this way. No disease entity, no champion has ever come to our lab and said, you know, solve this problem or advance my field. And we treat this as a real responsibility and commitment to. And I assure you this money will be spent in the most creative, most ambitious way possible. All right? So thank you.
And Todd and I
have
are
a
sitting on the
question,
advisory board. We will report back to you from time to time, I promise.
I'd like to ask a question. So when you do clinical trials for this, do you go through drug companies that would possibly be the ones to make the drug, or are you doing clinical trials on, like, do you have permission by law, I don't know how this works, to do clinical trials on people that just come to you to be clinically treated at the hospital?
Yeah. So there's two answers to your question. I don't know if you heard, but question was, when we do clinical trials, building off of this research, will it be on our own or will it be with drug companies? It really depends on who made the molecule. It's almost always with drug companies because Dana-Farber, while we invent drugs at Dana-Farber now, and that's a new thing over the last 5 years, we're not a drug manufacturing company. We don't sponsor our own clinical trials. We have a conflict of interest policy that I co-wrote that prohibits it. So we will always work with a drug manufacturer that can provide us this special material. But our sarcoma doctors will design these trials with these molecules and to use them in a population that it's fair to say the companies may not know as much about.
Okay.
Yeah. So it'll be, that too will be collaborative with industry.
And we actually have a brilliant guy who happens to be the guy I traded apartments with, who is who's a professor of biochemistry at Harvard, but is also in the private sector, and right now is in the private sector, and is very interested, once the molecules are discovered, in taking this to the therapeutic level and making the drugs.
Because you have to have a drug company who will want to
Yes.
make it.
Yeah, and whereas a lot of academics might download the data, I bet you every major pharma downloads it right away.
Yeah.
We have Johnson & Johnson, Novartis, a handful of companies already just heard through the grapevine, and I think it's those Shrivers. They just heard through the grapevine that we're doing this, and they're dying to know what targets we find.
cool.
Because what they then do is they look at the targets and they say, well, what do we already make a drug for? And maybe they can now repurpose something on their shelf for sarcoma treatment. We'll see. We'll see. But if they won't do it, we'll make our own.
But you're making the recipe for the drug, and then the drug company will make the recipe.
When the drug originates with us, yes.
You're doing the
But
recipe.
one of our favorite things to do is to make somebody else's drug work better. That's the gist story. So what drugs might pharma have that we could repurpose with this new knowledge? Yeah.
Thank you all. Thank you for coming.